Now here in this case, x double dot plus kx k by mx equals to 0. That is one thing, and that is so. This is your simple harmonic motion equation, SHM equation. And when we are comparing this equation with with our vibratory motions equation, we can find that omega n is to be written as under root k by m. So with the help of this, आपको अगर पता है कि k, that is k here is you define as your restoring force constant. तो k जहाँ पे spring है तो that is k is defined as spring constant, and m is the mass of the body, right? So with the help of this simple equation, we can find out your circular frequency, or you can say a natural frequency of a body omega n, which is to be written as under root k by m, and this equation is in radian per second. Clear? Okay. Now you can see that what are the things to be written in these notes. So with respect to notes, I'm going to explain you that the forces acting on the masses are first mg, which is defined as a gravitational force or which is acting vertically downward. AST, that is a static deflection vertically upward force. As per the Newton's second law, uh, inertia force is equals to mg minus k delta st plus x, and from this equation you will find that mx double dot plus kx equals to 0. Now x double dot here in vibration, we generally write acceleration in x double dot, like x is your displacement, right? And dx by dt can also be written as x dot, and which is the form of velocity. Likewise, when we further differentiate velocity, that can be written as dx square upon dt square, d square d square x, and that can be x dot, or you can say x double dot, that is defined as your acceleration. Is it clear, class? Is that clear to everyone? So x dot and x double dot in vibration, these are the terminology used in the vibrations topic. Now you can see that x double dot, ये equations आपने लिखा, this is the one, that is the standard simple harmonic equation. So omega n can be written as, if you are comparing this one, omega n is equal to under root k by m, or yes, this is important. We have already defined that k mg is equals to k delta st. Yes. So k by m, that is k by m, can also be written as g by delta st. So g by delta st को अगर आप देखोगे, when it means what, कि natural frequency can be written in the form of under root k by m, and it also to be written in the form of under root g by delta st, right? Now time period, we have defined time period. Time period क्या होता है? Time period is equals to 2 by omega, right? So that is defined as a time period, and frequency is defined as 1 by t. That is your time period. So it means what? If it is to be 1 by t, then it is to be written as omega by 2 pi. So omega here in this case is defined as your angular frequency, and f is defined, frequency is defined as your linear frequency, and both are to be called as natural frequency on the basis of units. Like frequency is in hertz. On the basis of units, you can identify this is your natural frequency and this one is your linear frequency. Is that clear to everyone? Aditya? So the natural frequency, you can say that it is 1 upon 2 pi under root k by m, or time period is also to be written as 2 pi under root m by k. Now, this is one of the method. This is one of the method of finding natural frequency longitudinal term में. तो हम I'll just revise one thing. Longitudinal free vibrations को अगर equilibrium methods के through समझने की कोशिश करें, then it's your natural frequency is under root k by m. If any of the data is to be given in the, of the values given, like spring constant is given, mass of the spring given, then you can find the natural frequency of the system, right? Now this is going to be explained with the other method also, which is known as an energy method, right? So with the help of energy method, we are going to explain the natural frequency of free longitudinal vibration, right? So this is the same diagram which we have seen in this equilibrium method. Now in the equilibrium in energy method, we are going to see what are the energies. You know that energies, like it is to be of potential energy, it is to be of kinetic energy, it is to be of spring energy. So but here we have just described in a different other forms. Anirudh, are you there?
Yes, sir.
Okay, great. So you can see that when the body is in a motion, it is defined as your kinetic energy, right? And it should be written as half m v square. But in vibration, it should be written in the form of half m x dot square. Clear? Now the potential energy. Here, in the terms of potential energy, there are two types of potential energies. First one is your gravitational potential energy due to its elevation from the reference point. You can see that the mass at the mean position, then mass at the maximum displaced position, either downward side or at the upward position. So if the mass is having elevations, then it have potential energy. That is a gravitational potential energy, right? The third part is your potential energy in the form of strain energy, that restoring energy जिसको आप बात कर रहे थे. So here in the case of spring, it is defined as a spring energy. Clear? Okay. So with the help of these three energies, we are going to solve or define this condition. The first point, if the reference level as an equilibrium position, the gravitational energy is minus mgx. मतलब अगर ये आपका आपका एक equilibrium position था and you displaced x position, so when you are decreasing, your gravitational energy decrease होती है, right? So it is to be written in the form of minus mg. At this particular position, your gravitational potential energy is minus mgx. Now, what is your spring energy? Spring energy, or you can say a strain energy, is defined as the work done in deforming the spring through x distance, right? So, if you are going to find out the strain energy or spring energy, you only need to find out the work done through a displaced position from 0 to x, right? Okay. Example position, the spring force K delta st under stressed condition. जैसे ही displaced position आया, that can be written as K delta st plus x. This is the mean position. At mean position, spring force is acting as K delta st. At the stressed position, the spring force is acting as K delta st plus x. Is that clear to everyone? Can we move ahead?
Yes, sir.
Okay, great. Now here you can see that the average force. So the average force, this is the position, this is the mean position, this is the displaced position, and the average force is this plus this plus this divided by 2. And you can see that this can be written as k delta st plus kx by 2. This is your force. Always remember. So what is your work done? Force. This one is your force into displacement. So this is your spring energy, or you can say strain energy, which can be written as k delta st into x plus kx square by 2. Okay. Now here you can see that k delta st can also be written in the form of mg, which we have already defined. So mgx plus kx square by, right? Now kinetic energy half mv square half mx dot square. Okay. Now when I say this is an energy method, so one thing is always remember in energy method, right? The total energy at any particular point, the total energy at any particular point. Suppose if I say the body is at here at the mean position. Second, the body is at the displaced maximum displaced position at the upside and the downside pole. At the mean position, you can say kinetic energy is maximum. At the displaced position, you can say the potential energy is maximum. It means what? As per the first law of thermodynamics, energy cannot be created nor destroyed. It changes from one form to another form. It means what? If the body is moving from mean position to the displaced maximum displaced position, at the mean position, if kinetic energy is maximum, then from displacing from the mean position, this kinetic energy is reducing and changing in the form of potential energy. So you can say that if kinetic energy and potential energy is constant at any particular position, right? The summation of kinetic and potential energy is constant throughout the motion. At one position, you can say this is of the maximum value. At other position, say you can say the kinetic energy is maximum, but in between the energy, the content of the energy is constant. So you can say the total energy. So total energy, if I say is a constant, the total energy is what? Summation of kinetic and potential energy plus gravitational potential. So here we are going to write this expression: half mx dot square plus mgx plus kx square by 2 minus mgx is equals to constant. So here you can see that mgx minus mgx and mgx cancel out, and you can get half mx dot square plus half kx square is equals to 0. Right? Now, sorry, this is constant. This should not be 0. This is the constant. Now, when you are going to differentiate d by dt of this equation, then this constant of any derivative should be 0. Right? Constant of any derivative should be 0. So you can what are the derivatives of this one? Half m. This is your velocity. So that is 2 x dot x double dot plus half k 2x into x dot, and this equation should be 0 because derivative of constant is always 0. this 2, this 2, this 2, this 2 cancel out, and you are going to take x dot common, and your equation reduces to mx double dot plus kx equals to 0. Now, one point is worth remembering here is that the product of your velocity and the summation of mx double dot plus kx is equals to 0, right? Yep. Okay. Okay. The product of x dot and this summation, this equation is equal to 0. It means what? Your x dot cannot be equal to 0. Always remember. This shows velocity and your body is in motion condition. So it is not possible that in velocity should be 0. So you can say that the equation of x double mx double dot plus kx should be 0, right? So we can see that the x double dot plus k by mx equals to, that is another form, और यहाँ पे आपका ओमेगा n can be written as omega n is equals to under root k by m. Clear है? So with the help of this you can also find out, this is your energy method, and the same result we have been obtained as compared to the equilibrium method. Do you have any doubt, class? Is there anyone having any doubt? Class, students?
No, sir.
Yes?
Yes, sir. Clear, is, sir.
Clear hai? So now we are going to move ahead, right? So we have two methods now to find the natural frequency. The first method is your equilibrium method, and the second method is your energy method, right? Now the system, when the system having angular motion, now this is interesting and this one is important also, right? So system having angular motion. So suppose one bob, or you can say the weight is hanging on a string, and if we are going to displace it to displace its mean position, so this one be your mean position, right? And your body is behaving like this after displacement. So it is moving in this particular position. Yes or no? Right? So at this particular position, when you are going to displace, so always remember what are the forces acting on a displaced position, and on that basis, we are going to define the equation of vibratory motion. Yes? Okay. A small amplitude, I'm going to just read this. A small amplitude of vibration, the displacement of the bob may be considered as x is equals to L theta. Suppose this is your length, of this one, right? And a very small. So this is basically you can say a curve. If we say that we have displaced a very small x, so this is, suppose karo r है. So how you are going to find the distance of r? X is equals to L into theta. यानी कि arc is equals to radius into the angular displacement, right? So if this is very small, then arc is normally equals to x is equals to L theta, right? So at the particular displaced position, let us understand what are the forces acting. At the displaced position, we can say that by D'Alembert's principle, here इसमें एक restoring force होगा जिसको आप inertia force बोलोगे, ठीक है? That is of J जो angular displacement के साथ opposite direction में act करेगा, plus इसमें जो weight है that is also to be acting in this particular direction, right? So here in this case, this is also acting in this in, toward its mean position. So we can see that in this angular motion, there are two forces acting. The one which is defined as your inertia force, angular inertia force, and second one is your gravitational, right? So mg into x distance. So at this point को आप observe करो, तो at this point एक जो torque act करेगा वो magnitude कितना होगा, force mg, that is the weight, into the displaced position. So with the help of this D'Alembert principle, we can write j theta plus mgx is equal to 0, right? Here in this case, x is what? L theta. So j double theta dot plus mgl theta is equals to 0. This is the required equation of your angular motion. Now this can be written in the other form. Therefore, theta double dot plus mgl by j theta is equal to 0. That is one of the equations. And when you are comparing this with the simple harmonic motion, you can find that if j at the moment of inertia is ml square, then this can be written as m. J can be replaced as m l square. Then m cancel out here. L square can be cancelled out, and it should be written as g by l. So the required equation is theta double dot plus g by l, which if you are comparing this equations with your SHM, then omega n is equals to under root g by l. This is the natural frequency, you can say, of this angular motion. Is that clear to everyone, class?
Yes, sir.
Okay, okay. Now moving to this, we have one you can say question. Can you please solve this question? This one, I'm just going to draw this question in another paper so that it can be clearly visible to you. Class, you only need to find the natural frequency of this particular system. Yes. Can you class please solve this question? You have only 3 minutes to solve this question. Or if not, then I am going to explain you this particular. This is your L. This is your suppose A. This is the particular position A, right? we have two methods to find out this question, right? We have two methods. First one is your equilibrium method, and second one is your energy method. So with the help of these two, we'll solve both the. Now in the first part, we are suppose if we are going to solve with equilibrium method, right? In this equilibrium method, you only need to follow the D'Alembert principle, right? D'Alembert principle. And what D'Alembert says, like this is suppose you only understand this is x displacement. Suppose it is to be displacement x, and this is of angle theta, right? So if anyone asks you what is the displacement in this spring, then it is to be x dot, and here displacement is considered as your x, right? So x dot, if it is a very small displacement, x dot can be written as a theta, right? This is also considered as an arc, and x can be written as L theta. Yes? Okay. Now here in this condition, you can see that the weight is acting here in this particular direction. And suppose this is your mg. Then when the force is acting at this particular position, this component is mg sine theta. If this is your theta. Yes. Then your equation should be, now at this particular position आपका एक स्प्रिंग फोर्स एक्ट करेगा क्या, जिसको आप बोलोगे k x dash, right? K x dash. Now we can write that when we display this position, आपका opposite direction में एक force act एक inertia act करेगा, because this body is moving in this particular direction. Your inertia force is phi theta double dot, right? Right. So we are going to see what are the forces at this particular position. At this particular position, you can see that you have inertia force, you have spring force, and you have gravitational. जो mass है, that force. So we can write that I theta double dot, right, plus kx dash into a, that is this one is force, plus, because at this particular point all forces are moving in clockwise direction, plus kx dash a plus your this equation, which can be written as mg sine theta into L, and as per the D'Alembert principle, this should be equals to 0, right? Right. So I theta double dot plus x dash, you can see that x dash can be written as a, then a square हो जाएगा, that is theta plus mg. अब always remember this sine theta, because if theta is very small, then sine theta can be written in the form of theta into L equals to 0. Now I theta double dot plus a square plus mgl theta is equals to 0. So you can say that this is the required equation. So theta double dot plus k a square plus mgl by I into theta is equals to 0. Therefore, omega n is nothing but ka square plus mgl upon moment of inertia. So this is the equation of natural frequency of this diagram with the help of equilibrium method, right? Now we are going to find out with the help of energy method. So in energy method, you need to understand what are the energies acting on this particular position. So here we have kinetic energy, right, which is half a x dot square, right? Here you can say that that is of kinetic energy and potential energy. Uh, Sorry, this is your potential energy. I just clear it all. So I need to draw it again. Okay. Suppose, chalo, this is one of the position. This one, and suppose this is the position. So this one is your x displacement. This is a. This one is your theta. This one is your L. And with the help of this, we are going to find with the help of energy method. Energy method. So kinetic, you can say that the kinetic energy of mass is to be written as half I theta dot square. Similarly, potential energy of spring. Spring is having potential energy which is to be written as half kx square, right? Kx dot square. Then kx dot, this is your x. It can be written as half k. X dot means your a theta. A theta square, right? Now here in this condition, and potential energy of mass is to be written as how much distance is to be this one. So you can write that is h, so which can be written as mgh. If we are going to find out the distance of mgh, we can write that mg L1 minus cos theta, right? H can be written as 1 minus cos theta L, simple sir. You can also find out with the help of this geometry, right? So if we are going to differentiate d by dt of kinetic energy plus potential energy plus potential of gravitational energy is equals to 0. So we can write d by dt of half I theta dot square plus half a square theta square plus mgl1 minus cos theta is equals to 0. When you are going to differentiate, you can see that that is when we have I 2 theta dot theta double dot plus half a square 2 theta into theta dot plus mgl of this one is 0 because this is a constant minus, and it is to be the minus cos theta को when we are going to differentiate cos it should be of minus sin theta, तो हो जाएगा प्लस, तो आप लिख सकते हो mgl sin theta is equal to 0. If theta is small, then sin theta can be written as in the form of theta. Then this equation 2 2 2 2 cancel out, and mgl में sin को cancel out कर दो, तो आपकी इक्वेशन बनती है into theta dot also. Then theta dot कॉमन लिया तो आपकी इक्वेशन बनेगी I theta डबल डॉट प्लस a स्क्वायर प्लस mgl theta is equals to 0. Then equation of this one can be written as I theta double dot plus a square plus mgl theta is equals to 0, right? Then theta double dot plus a square plus mgl by I theta is equals to. So this is your natural frequency of this one. This can be derived both with the help of, this can be defined both with the help of equilibrium as well as energy. This method is clear to everyone, class?
So x dash क्यों लिए?
X dash because x, तो ये इस पॉइंट से आपका स्प्रिंग कितना डिस्प्लेस हो रहा है, राइट? दिस डिस्टेंस कैन नॉट बी इक्वल्स टू दिस वन ना, बिकॉज आप अगर आप यहाँ पे देखोगे, सपोज दिस इज योर आर्क, राइट? एंड आर्क आपका क्या है, आर थीटा पे डिपेंड करता है, आर इज द रेडियस. तो इफ दिस सर्कल के लिए आर्क आपका ये ए रेडियस होगा ना, और दिस सर्कल के आर्क आपका ये होगा, so this distance is also to be different ना, this can be written as x dash and this can be written as x.
वैसे तो उसका फोर्स कैसे अप्लाई होगा?
किसका फोर्स?
सब सर डीएमएल में बताया था ना कि फोर्स अप्लाई होगा, मतलब सर वही टॉर्क कैसे अप्लाई होगा एक्स डैश का?
इसमें कैसा है कि जब ये बॉडी इस डायरेक्शन में मूव करती है तो इसके ऑपोजिट आपका इनर्शिया फोर्स लगा, इसको आप आई थीटा डबल डॉट बोल रहे हो, राइट? अब इसमें जो है यहाँ पे आपका mg फोर्स लगेगा, इस डायरेक्शन में आपका mg cos थीटा